Welcome to This Explainer. Today we're diving into some really fascinating insights from Anand Vemula, all about the future of large language models. Now, if you've been following the AI space lately, you'd probably think the whole industry is just in this massive race to build the biggest model possible, right? Well, Vemula's work presents a seriously compelling counter-narrative. The future of AI actually isn't just about raw size or massive parameter counts. Instead, it is entirely about smarter, highly targeted customization. We're going to break down exactly how organizations are taking these massive, general-purpose models and turning them into incredibly specific, highly efficient tools for their own distinct needs.
Let's take a quick look at a roadmap. We'll cover the era of smarter adaptation, weigh fine-tuning against few-shot learning, dive into the parameter-efficient approach, look at real-world enterprise impact, and wrap it all up with ethics, governance, and the future.
Section 1. The era of smarter adaptation. So we are in the middle of this huge, fundamental shift right now in the AI landscape, and it means completely ditching that old one-size-fits-all mentality. When you look at how crazy the evolution of generative AI has been over the last couple of years, it's super tempting to ask, do we just need to keep going bigger? Like if 1 trillion parameters is good, is a model with 10 trillion parameters automatically the magic bullet for all our enterprise problems?
The research emphatically answers this with a hard no. The real competitive advantage out there doesn't come from just having access to the biggest model in the world. It comes from adapting these models for specific domains. Think about it. A giant model that knows a little bit about everything is great for, casual chatting or writing a quick email. But for serious enterprise data science, you need a model that knows absolutely everything about your specific industry. That smarter adaptation is where the real magic happens.
Moving right along to Section 2, fine-tuning versus few-shot.
Okay, so how do we actually get this domain-specific intelligence? The first big method is fine-tuning. According to the research, this is basically the process of adapting models using your own domain-specific data to significantly boost task performance. It's kind of like taking a really smart generalist employee, maybe someone fresh out of college, and sending them back to university for a super intensive, highly specialized master's degree based entirely on your company's proprietary data. You're literally wiring your industry's language and nuances right into the model's core intelligence.
Then on the flip side, we've got few-shot learning. This technique lets models tackle new tasks with just a handful of examples, which completely slashes your deployment overhead. Going back to our employee analogy, few-shot learning is like handing that same smart generalist a quick one-page cheat sheet right before a major meeting. You show them a couple of strong examples of what you want, and boom, they instantly grasp the new task without needing a 2-year degree to figure it out. It's fast, it requires minimal data, and it lets you pivot on a dime.
So what we're looking at here is a really classic trade-off. Fine-tuning gives you that deep, incredibly robust task improvement. Yeah, it takes more data and compute power up front, but the resulting performance is incredibly high. Few-shot learning, though, that gives you serious agility. Minimal examples and a super low deployment overhead make it totally fantastic for rapid prototyping or tasks that change all the time. Honestly, understanding this contrast is basically the holy grail of modern AI engineering.
Which brings us nicely to Section 3, the parameter-efficient approach.
Now, how do you get the best of both worlds without needing to buy a supercomputer? Enter parameter-efficient tuning methods. Instead of retraining the entire massive model from scratch, which is ridiculously expensive and time-consuming, organizations are updating just this tiny little slice of the model's parameters. We're talking maybe 5%. The vast majority of the original model, that other 95%, is completely untouched. This drops compute costs by a staggering amount, sometimes over 90%. While surprisingly giving you incredibly strong, highly specialized performance. It's an absolute game changer. And this is exactly why we're seeing a massive shift toward hybrid approaches. Imagine utilizing that parameter-efficient fine-tuning for the core, unchanging rules of your industry, and then mixing in few-shot learning for your agile, day-to-day task variations. Enterprises can achieve this highly customized, ultra-intelligent AI, but with a fraction of the deployment headache. It is literally the sweet spot for digital transformation.
All right, let's hit Section 4, real-world enterprise impact.
Let's ground all this in reality, because the real-world impact here is absolutely huge. Take healthcare. A generic model is going to stumble over complex medical jargon and privacy rules, right? But a domain-specific fine-tuned AI processes that complex medical data with mind-blowing accuracy. Or look at finance. These adapted models are crunching proprietary data patterns to analyze risk and catch fraud. And in some cases, they're slashing false positives by significant double-digit margins. And customer service? We are way past generic chatbots.
Companies are deploying deeply tailored AI that knows their entire product catalog and customer history inside and out. In all these sectors, this tailored approach isn't just some fun tech experiment anymore, it's a critical competitive advantage.
Finally, Section 5, Ethics, Governance, and Future.
Now, you can't just build a highly adapted AI and let it run wild in your systems. Unleashing this kind of power means organizations absolutely have to follow a strict pathway. Step 1 is rigorous model evaluation. You have to constantly test the AI against your specific enterprise benchmarks. Step 2 is performance optimization, making sure that as the model runs, it stays sharp and doesn't degrade over time. And Step 3, ethical AI deployment and governance. If your AI is making highly specific decisions in finance or healthcare, having a framework that ensures transparency and compliance with regulations is just non-negotiable. It's just smart, sustainable business.
When we look at all these components together, the research points to a very distinct future. The next wave of enterprise AI is not about models that just sit around idle. The future belongs to systems that are continuously adapting to your business needs, seamlessly integrating deep, proprietary industry knowledge, and dynamically evolving right alongside what your users actually want. Adaptive AI isn't a static piece of software anymore. It's a living, breathing extension of your business intelligence.
So as we wrap up this explainer, I want to leave you with one final, critical thought to chew on for your own digital transformation journey. Take a close look at the systems you use today. Is your AI seamlessly adapting to the unique intricacies of your business, driving your specific competitive edge? Or are you forcing your teams to adapt their workflows just to accommodate a rigid, general-purpose AI? Honestly, how you answer that question might just dictate your organization's entire future in this intelligence era. Thanks so much for exploring this fascinating topic with me today.